Yes, good afternoon, ladies and gentlemen. As usual, and at the onset, we said we shall be sharing knowledge, and I've taken a lead to share knowledge with you guys. Today, I'm going to be sharing knowledge on bridge inspection. Sometime in 2010, we attended a training with a colleague of mine. He's now a managing director of Dynaco Limited. He's doing very well out there. He's giving us super fast bridges, and I do appreciate the effort to be taken by Professor himself. We attended this training in South Africa, Pretoria, I think Johannesburg, yeah. And the presenters were two very experienced and qualified engineers. One was Professor Rankine, who gave us a very good talk about bridge maintenance. So I think with all that from 2010 up to now, we also got our experience. We built on what he shared, and therefore I also decided that I will replay or talk about things in the order he gave, but of course to compound a bit in the way we have done ours. I think I've decided to do bridge inspection today. Then I think after another session, I will share bridge management, maintenance, where I think I've taken a lot of our own bridges here in Uganda, which are part of example. So I think here, this is where we are. So bridge inspection, session 2. I think this was the session 2. There's also session 1. We're quite a number. We are going to be sharing a lot. There's no need to keep this information to myself. It doesn't make sense. Let those who are interested, those who are in the bridge management system and inspection, let them also have a clue and a bit of glimpse on that. Inspection. First, someone will ask, why do you do inspection? But I think let's leave that question. You will know very well. As a designer, we said you design a bridge to last for 100 to 150 or even 200 years. And the longevity of a bridge depends on how best you do your planning for inspection and how you inspect these bridges in a structured manner. The inspection is done to identify any early defects that may arise so that you are able to address that as soon as possible, and you continue to enhance the capacity of the bridge and the durability to achieve the longevity. That's why we do inspection, to early identification of defects that may arise based on many things, environmental loading, uncertain events, things like threats from floods and earthquakes. You will see what happens. So that's why we do that. Equipment required, we do traffic. Normally when you're doing inspection, the traffic warning signs, very, very important, your personal safety. And then the use of personal protective equipment, like including wasp spray, gloves, ladder, the jackets, and the helmet, tools that you are going to have a look at. You need to have tools, you need to have cameras, binoculars, and so many. So that is what you need. And then these are some of the tools that we were presented with by Professor Rankine. There are quite a number. You have chalk line, you have chalk, you have plumb bob, you have torch, you have plus backup. Then you have spare batteries, because you may go after using if you sometime you use the torch and the following day you are going for another inspection, and therefore these torches are required because of some areas are dark, like box girders and the rest, so you have to go in and then do a bit of check. Digital cameras, metal detector, moisture meter, scratch armor, small scissor, nail targets, 30-meter tape, 5-meter tape, steel rule, engineer square, forensic ruler, crack, comparator, loop, mirrors, permanent marker, spray paint, and decreasing swaps, golf ball, feeler gauge, insect spray, sunscreen, safety glasses, plastic bags for samples, phenolphthalein, hydrochloric acid, barium chloride. Now, some of these things, please, it's very important. Can we get time? I've introduced to you. Please go to internet, look at and go one by one and get some notes on these things. Get to know the detail. Recently, we were inspecting Karuma Bridge in Uganda here, and the inspectors were coming in contact with snakes. This is black cobra that spit the poison. So they had to find ways of managing it. So if you don't have this spray and other thing, you definitely get into problem. Real problem in practice, not a theory. So these are very, very important. These tools are very important. Please look at it, and more you can look at in the market. Preparation for inspection. Yeah, look at the bridge file, read the drawings to see type of structure, obtain appropriate tools, read latest inspection report, because normally for bridges we expect you to have regular inspection, and then filing your inspection report, identifying defects, what has been done, what needed to be done. So it's very important that every inspector get access to some of this information. Read latest inspection report. List items where deterioration has set in so that progress can be measured. Check weather report for river bridges, arrange traffic control, access equipment, and also, like for us here in Uganda, where we have our stations in about 22 districts or 22 stations regionally, we normally inform our station managers in advance so that they notify those bridge inspectors with them, and sometimes help to make sure the bridges sites are cleared. You don't just go and because we deal with more of our 90% of bridges are basically river bridges. We have just started on road bridges like Kampala flyover, but most of our bridges are river bridges. So you have that earlier preparation to make sure snakes and reptile and other things, wasp and bees are all checked and then cleared. And then the inspectors are safe to do that. Very important. That's all under preparation. For road bridges, you need also traffic policemen to help in your access, and then you're going to see some difficulty in access, and you'll learn. Preparation is very important. Your safety is first. When we are doing our masters, the guys of SARE will tell you, go for your inspection, give us this report, but start with your safety. You don't just go because the lecturers ask you for things, you run in there and then you, no. Please, safety is first. Make sure your surrounding is okay, where you're going to access is fine, and all those things. Thank you. We go to safety consideration when surveying bridges. Traffic. Yeah, I told you you need traffic presence. The traffic officers need to be there to control the traffic. Criminals. Some of these bridges you're going to see as we move along, they are hideout of bad fellows. So like box girders, sometimes guys are hiding in there. You reach there, and the guy will just hit you with anything that they have. So you have to be careful. Sunburn, wasps and hornets, slipping and falling, studded rubber, soled boot, not cheap safety boots with slippery plastic sole. That's why your safety is first. You have to know, you have to get a very good safety boot, lighter and everything. You have to be careful of slipping off and falling. All that you have to know. Stepping, where you're moving, check before you do anything. Very important. The bridge you inspect could well be somebody's home. This is very, very important. This guy is under the bridge. Seems to be a Batman area. Be careful. You get it? You may think you are disturbing him, but you have to be careful. Now you can see the box. This is the box girder. Now what is happening here? Someone is always going in there, and seems it is this man. If not careful, we don't know. I don't know what it is. So be aware that bridges provide shelter for many homeless people, criminals, and vagrants. The hollow box girder of this bridge over the intersection of Barry H. Jog and Empire Road in Johannesburg is inhabited by vagrants. Not the pile of bricks below the opening used to gain elevation for access. Note also the black discoloration caused by the burning of fire inside the box for heating in winter. Never inspect bridges alone. Take an assistant, take a cell phone so that you can call for help in the event of an emergency. Personally, when I go to site, my driver has become my assistant in terms of he understands what we do. If it is a bridge, he will know what to do, even helping with the tape measure, moving around, very, very important. He doesn't leave me alone, and he is improving that, he's a friend, just because you may not be getting assistant everywhere in government. Normally, there's no assistant. Everyone is an officer doing work. So you make good use of your driver so that they become holistic. You understand what you do and can help. So very important. This is you can see, and this affects the bridge performance if it is not arrested earlier. Now this is where you talk about access. You see this is a busy road, and you can access from up, but down become a problem. This is now where police has to come in, and then on either side to control, and then you are able to do that. So not the height of the banks and the bank angle. You can't just move in there. Everything, preparation is very important. You need to know, how do I access this? How do I control traffic so that you are able to spend one or 2 hours here? Very important. This is how access can be done. Special mobile access equipment. Definitely in Uganda today we have this overall bridges, the Nabigirwa, the 1.5 kilometer, the Nalokolongo, Busega bridges. This kind of trucks here, this specialized equipment, we need them. The New Nile Bridge, Para Bridge, which is a half a kilometer, and then we have a Simba Bridge, is almost a kilometer. We need to have this specialized equipment so that they can inspectors can gain access at height to begin inspecting and recording these bridges very, very well, and should be at interval or periods that can help. So this special equipment is very important. I know there is a plan to get an inspection vehicle for the Nile Bridge, but I think they need to have a look at have similar bridges now, bridge inspection vehicle like that. This is highly specialized access equipment, not also mesh enclosure used during repair. Now, if you look at Karuma during repair, this is what needs to be planned first. You plan this one, water is flowing at a very fast speed, and therefore you need to have safety and safety and safety of those who are going to do. The platform they did there and the lowering of people using the bucket is a very, very risky thing. But they managed to do it. But this is something that was well prepared. You can see the second slide with the inside of that. This is the inside of this. This is out. Then this is inside. You see all these hangars are all designed for. So even your design takes care of all this maintenance. So your maintenance must be part of your design. How do you make sure people are here, they can walk? If anybody fall here, will be trapped by the net. So you have your fast flowing water down here, like the Karuma, and you are able to do this. Very, very important. I know there's a plan for repair, and I pray that the contractor who has got the job has this kind of exposure and knowledge. Otherwise, it is going to be a joke. The water flowing there is not a simple stuff. So this is very important. This one is good if an engineer, the designer, understands this. Anybody can. It's very difficult. These are cross girders. These are the frame bracing, and these are the ones. The hangers are all designed for here, and then you all have this one here. Inside view of mesh enclosure underneath the bridge, used during repair. Very important. Drift and causeways, I think mostly outside. Well, I think here, if you go, it is actually in Karamoja region. They have a bit of drift. I've seen 1 or 2 with vented drift. So basically here that, and the causeway have not seen that. Drift at least I've seen. So they are saying you always for repair, you do clean surface with the spade and broom, simple stuff. Inspect deck for damage or erosion, because every time water is flowing, it is partly submerged. So it is subject to a lot of clogging and other things, and debris heaping on top, so it has to be cleared on a regular basis whenever it is raining. Check inlet, outlet, and barrels for damage. Check channel up and downstream. Check roadway for rutting. Very important. This is now good design of a drift over the Groot River near Steylerville. Source is W.J.R. Alexander. Please, you will have all this. Try to Google this and get a more detail and read about this thing. Mine is only to expose you to this, and then the rest will be you. And then we have a causeway, small causeway, with a good sign. It's here. And then I think we have more. I think this is the other one. So this is a small causeway in Modderfontein. Just Google this and get more about this thing. They are all there on the internet. This one for us here, we would call it culverts, pipe culverts, but this is how they're calling it, causeway over Pongola River. You can see they're trying to maintain, they're working on river training works. The guys are here, committed fellows. These are things that really can encourage everybody. What about culverts? Inspection of culverts, you have to clean the head and wing walls with. So you inspect culverts to identify if they are blocked. How the culvert head walls are working. The culvert, is it silted? Is it performing as designed? If it is silted, then recommendation for maintenance comes in. Actually, inspection is on the critical path. You have to inspect before you come up with maintenance planning. So it is inspection that derive the maintenance planning. So clean the head, wing walls with spade and broom, look for cracks and traffic damage. Now during inspection you have to, because if you don't clean it, you will not see all those things. Check inlet, outlet and barrow for damage and obstruction. Check channel up and downstream to see how the aprons are performing. You may find that your culvert from the inlet point is now being squared outside the culvert perimeter, kind of, the culvert circumference point. And therefore, you will try to arrest this piping as early as possible and you block it. Very important. No piping is one of the worst scenario for our box culvert and pipe. Every time it rains, you have to know that not all water will be entering through the barrow. Some will go because of clogging, blockages, and the rest you'll see blockage. Then that is where you get into problem, and so the culvert get washed away. So check embankment both sides for erosion, very important. I talked about eddy currents, water get disturbed or obstructed as it is leaving, and also as it is getting into the culvert, and that creates kind of surge and it's turbulent behavior, and so it starts eroding an embankment, and that one also is not very good. You have to, because in our design we talk of laminar flow or uniform flow, steady flow, but now because of uncertain events like blockage, water flowing with tree stumps and the rest, it tends to block, and then water will start fighting, and that fight will lead to something else. This is the silted up arch culvert, Molalesa, Limpopo. This is an arch bridge, this is stone. These are all designed that many young people always try. They are eager to learn how to design this. So it is important that some of these young guys, these are some of the research area you can try. This is now how do these things happen? A road is getting cut off. Maybe there was a culvert here, and this culvert does not have proper access drain, proper head wall to guide, and water begins to play around, and every time it rains, you find now there is this problem, and before you know it, the arrow is showing you where it's going. So you need 1 or 2 rains and it's gone. Even one, it's gone. So road damage during the 2000 floods, I think this is the source. In more than 2000, so many years back, but we now need to begin also updating some of this. I think in our following knowledge sharing, we shall get some similar failure kind of scenario, and we replace it. We don't replace, we just have another one, so that we need to see how this similar occurrence on our roads. Very important. Now this is where you need to cordon it off for safety of road users at night, and so you see it is part of the lanes already taken. So if you don't do this, hour alone may not be good enough. You need to barricade this using crash barriers so that people are aware, and you narrow it and you put signage far, 1 kilometer away or 2, and then people are aware. Concrete bridges, Now for superstructure, you need to inspect, clean the deck as you prepare walkways and gutters. You find scarpers, deck drains, and clear them if possible. Look for cracks and traffic damage above and below deck. Check the movement joints. Check asphalt on bridge deck and at adjacent roadway. See how they are performing for functionality condition. Look for settlement at the junction of bridge and embankment. That is the deformation at the transition between approach slab and the bridge deck. Normally there's that deformation we have. You have that deformation as you're approaching. So then we have a bumping effect. So every time you're reaching the bridge, you hear a bump, And so that means that the approach road is deforming now, the settlement going on. So that need to be. If your approach slab is a meter below, then you need to come up, remove this thing, fill it up compact, and then do another asphalt concrete. If it is flashing with the bridge level, then you just see what happened. Because once it's got deforming, then the approach slab start behaving like structural, and yet you didn't design that structure. So it start cracking and failing. So you need to know that there's really settlement behind the abutment. So local settlement, then also check bridge furniture, hand railing, lights, all those things. Those are part of your inspection. And it is very important that normally for me how I approach it is you start from the railing approach roads, then you come to all the way the bridge is, then you go to on top of the bridge, look at the gut rails, look at the deck drains, look at the raised walkway, look at the services, look at the asphalt concrete, and then you go down on a bridge. Look at abutment, look at the pier, the bearings, look at the coast, the river extent, the river banks, the gabion work, see how they are performing. So your report will be in that subheading, and you don't get it wrong. Very, very important. So that is the order normally I do. This is now failure at the deck drains. They call it blocked scupper. So now you find this area because of siltation. Every time it rains, you find, and even you can see a cigar here. Guys were smoking. These are things that are dropping here. I hope it was not the inspector. Okay, so that is the blockage, and this is how you can see. You have done your drawing very well, and you believe it's going to perform, but in practice, this is what happened. You see, this is how bad it is. I have ever told you. Someone else is going to implement and manage your design, and that's what happened. This down pipe is very short. We normally want it to come below. This is a box girder. They just truncated it. Detail of bridge deck scupper. That's the deck drain. And then this is Sunrail South Africa. So you have this drainage scupper, grid inlet, path section. With this one will be pouring water, but if there's wind, this water will be thrown into the surface here, and before and now it's going to start affecting the durability. This water is not clean water. Anything that comes from top, you don't know. It has some contaminants. So it's always supposed to be given down and below, at least 100 millimeter below the bridge deck. Okay, this is how the deck can block. You don't see now he is punching it here. You can see down, and this is when it is blocked. You don't even see. That's the position of a blocked scupper, and this is some scupper now partially cleared. So you have to open it. We don't need to allow it to reach this stage. It has to be done early enough. This is a nice bridge, but look at this arrow. They are draining the deck, but look at this coming. So when it's raining, all this surface will be affected. It's in line with the bearings, and yet bearings are supposed to be free from exposure to chemicals and oil. Now, if you have surface water coming splashing here, you will not know what's happening to your bearing, and you'll find there's a problem. So spouch pipes should be of a generous length so that water is diverted well clear of the structure. Generous length, good definition by professor, but you must have proper down pipe, and this down pipe must come in and move along the pipe and discharge it here, down here at the road level. So the road, this is an island kind of, it has also how the drainage is, so that drainage ditch here, or the side drain, should be good enough to receive water from up. So that's the one need to be done. The one for the abutment must be done at abutment point. The one at the pier must be done at the pier point. Very important. This is now where when you have the joints, you can now see the discoloring here. This one, every time it's raining, water is coming down, and this is now where expansion joint, if it's not done very well, become a weak point for the bridge, because every time there's rain, flash flood, everything coming, you have the chemical getting access into our bridge, and then if the cover is not good enough, carbonation start, and then not long enough you'll find your bridge is getting deterioration because of corrosion and other things. So this one, you can see that the professor is saying, not the presence of water staining on the decks of it, a clear indication of deteriorated bridge jointing sealant. Basically, that's what he's saying. And that is not only the sealant failing, it degenerates into the structure or the structure of concrete. You can see even already here, there's already breakage here. It starts breaking. So that is very, very important. We need to attend. Now, deteriorated movement joint on a simply supported road bridge servicing a gravel road. Note the stones which have worked their way into the joint, preventing the joint from closing during hot condition. Here it is white, here is blocked. This one will create a lot. The stress distribution here will affect the concrete, will affect the bridge behavior, and this one requires regular maintenance, and that's where normally we fall short of that innovation or focus. And therefore, when we design bridges to last for 100 years, definitely our bridges do not last. And we always fear to talk about the what is causing that premature failure is because we design, construct, and forget. It is high time that we need to begin writing and talking to the money people to make sure that actually it is important that at design stage, your construction cost must have part of the maintenance cost. Your operational maintenance must be part of the total project cost. Therefore, it is the release time that will vary, will be different. If you release the one for construction, and then the other one will now come maybe after first 3 years, 4 years, 5 years, it has to be part of that, so that when you are presenting that to government or to your management, we are not only giving the construction. So even when your construction cost is increasing, you don't go into that cost plan for the maintenance. It has to be a separate one. So it's very important. Now this one, now you are moving to some science. We always read and hear about expansion, contraction. And we always say, okay, for a bridge of 20 meters or what, you calculate the movement from understanding its linear expansivity of the material. You need to know the length of the material of that of the concrete section, and you need to know the difference in the temperature. Now, once you calculate that, you are able to know the deformation or the expansion or the movement, and that one. And then with other factor, you need to also put in, like if it is a bridge deck, you need also to look at any earthquake effect, movement, and also you need to look at. We've now talked about temperature. Then we'll talk about even movement due to dead load movement. When the bridge is bending, there's a way it moves. When any load is acting, there is that deformation, there is that bending, there is that shearing, there is that axial load. Then the braking force also can cause something. So when you do that, you calculate all that accumulated, and you know the span or the gap that you require. That gap must be maintained, and it must breathe in and out. It's breathing in, I think, when it is contracting, and when it is breathing out, it is expanding. Either way, you can interpret that. Don't worry about that. So you look at this, they are telling you that the following picture show what can happen if joints are not properly sealed, or if sealed joints are not adequately maintained. If it is a block like the one of the gravel road, if you block it, it never expand. As it's trying to expand, that then the stress start distributing onto the structure which was not designed for, and you start experiencing cracks, and this lift happen. So the joints open and debris enter when the concrete expand during hot weather. This is what happens. During hot weather, it's expanding, the joint is not working, it lifts. These are all failure due to joints not working well. You see the concrete is lifting because this area, instead of breathing in and out at that point, is now not doing it. Look at all this failure. See all this. Look at more here. We look at all this. They are telling you the sidewalk was built with expansion joint. Only at the end, they never considered it. So sometimes also we need to be very, very careful. What are the requirements for us to put in the expansion joint? This 25 meter, this 30 meter, which area? That has to be, we need to take care of. Is it at corners or what? All this central island on this road, bridge, over N1 highway, neglect of the joint ceiling has permitted ingress of dirt. This has prevented the joints closing during hot weather. Not the expulsion of the rubber joint seal as well as the lateral displacement of the island because of the skew western joint. So you can see all these things happening. You can see this expansion effect, all that. So basically, it is real in practice that temperature do affect our structures. So as a designer, please, you spend time designing, but also spend a lot of time to think through your maintenance, what could happen, how should it be done during construction, and so that should be part of your contract document. All these are problems. Close-up view showing displacement of concrete. Then all these are problems. Not the tightness of the joint. Now on the right hand side, as well as the concrete spoil in the corner. This now you think about how was this thing done. Maybe the joint also was not done good enough. Instead of having a 100 millimeter joint, you could have squeezed it on a 50. Then you put in your rubber, and when it is trying to expand, it gets resistance and poops, the whole thing gets out. This is the bridge movement joint. This is now a design of elastomeric with metallic runners cast into deck. These are the details. You can look at it. The source is USL Bridge Joints UK. Very interesting. You can look at it. This is the gentleman also looking at installing new joints at this expansion. Very important. These are now what they call enhancing the capacity and durability of your bridges. Now, for most bridges, you have the expansion joint, you have the bearings, you have the asphalt concrete on top. These are some of the aspects, the component of bridges that need to be replaced with time. This expansion joint could be about 15-20 years. So once that is done and you have maintained it well, then after that time you come and replace. If you don't and is exposed to harsh environment, then you will replace it sooner, which becomes costly. Then also bearing need to be replaced maybe after 20 years, depending on the design life of the bearing. What they call the maintenance-free life of those bridge components. Very important. This one is a metallic one. You can see once this area is locked up, fixed, and this one has slot. This slot is designed, balls are here to prevent lift, but horizontally it can move, sideways cannot move. So you guide it, so the thing will be moving in and out, moving in and out. Stainless steel cover plate to provide mechanical protection to the pedestrian walkway of the Nelson Mandela Bridge. You can now go, just Google the Mandela Bridge, you will go and get this thing. This is now corrosion. So they are telling us always that check bridge furniture, including handrailing, signage, and lighting. Are all the balls and fasteners holding it in good condition? Are all the parts there? Theft of these items for scrap metals is rife, particularly bridges with aluminium handrailing and bronze plate. So please, once you go for inspection, don't only look at the top. Look at the component round. Try to understand. Once you understand the functionality of that, the performance of that bridge, you can't get it wrong. If there are balls, you have to look at both the nuts area, the end area, the washers. What you see now here, the washer is gone for this one. While this one, but they're all cracked, they already failed. So this one definitely is due for replacement. They've even delayed. So that one is very important. Concrete bridges substructure system, which now comprises pier support system and abutment. Locate and inspect the bridge bearings. I told you, you need to understand the bridge you are going to inspect. You know the drawings, you have looked at it, and in order, you plan even in your checklist, you have it. And then you are able to look at all this, and then you are able to look at this thing and inspect at ease. Check abutments, wing walls, and piers for damage or cracks. Very important. And the direction, cracks, location of cracks, the length, thickness, this crack can be dormant cracks, can be active cracks. So it means if you are doubting, then there are areas that you can do to, there are things you can do to monitor this crack to see whether it is moving. So on a regular basis, you can do some taping there. If the tape breaks, then you know this thing is moving, or you do some marking, put it one side and see where it's going out. There are many things that you can do to check whether the cracks are active. Cracks mean they are propagating with time and because of loads. While dormant is maybe it happened and stopped, maybe because of temperature or shrinkage or something like that. Then expose footings and then make sure when the footings are exposed, please try to inspect and get to know. Our footing type can be piling, spread footing, everything you need to know. If it is spread footing that is exposed, you have to be worried because normally these things will go at least 2.5 or depending on the score depth. Until it has a fill. So once the fill has gone, then the stability can be compromised. And as an inspector gives you, an inspector also needs to have a bit of clue on the functionality and behavior or response of breach component. Very important. Once the breach foundation is exposed, especially for abutment, there is worry. Now your lateral force is one way. You don't have any restrainer and other things. You need to find a way of restoring that as soon as possible. Check embankment both sides for erosion. Very important. This is a bearings. You can see the bridge self, or what we call bridge seat, seem to be not being cleaned very well. So you can see cleaning is important because I've told you this water comes from up, and once it's exposed to this bearing, if it is elastomeric, and this one has component of oil and chemical, definitely this bearing will start failing because they are prone to that. Very, very, very important. This one is a bridge over the Orange River near on Sepakans. That is this. Now, what happened to this bridge? We can see it following. Underwater inspection. Okay, they are looking at how. I think this one is more of, I think the floodplain was big. They are fighting it. Now, of course, this one, the top of inspection, you can see on the bridge, you have to inspect both all upstream, downstream, underside. That vehicle seems to be very important also here for inspection. Underwater inspection, bridge over perennial rivers. Problem in Southern Africa is that water is often so turbid that a diver cannot see his hand when it is against his mask. In such circumstance, it is best to use an experienced concrete technologist or civil engineer who also has a diving qualification. Hey, very interesting. The inspection is done mainly by feel. So now the person who understands the functionality of the bridge should be at the same time a diver, because you cannot use a professional diver and then it will not give you a reliable information. Okay, fine, understood. There are new materials that can be used underwater to take an impression of surface defects in concrete, like dental putty. For underwater inspection, we did a rehabilitation of Nile Barrier Bridge here in Uganda, the Owens Fall Dam, in 2011-2012. The consultant was Mott MacDonald from the UK, and the contractor was Pencon Services. We had to subcontract this underwater inspection and work on our 15 pier columns to Subsea of South Africa. They were based in Mombasa, so they came. They did a very good. They were very interesting work done. We had underwater inspection camera. The divers knew what to be done. The water was okay because even the underwater camera was working very well. That is when you realize that actually there are a lot of roles played by different experts, and we need them at the time of need. So they did that. We repaired. They could do inspection all the way up to down. And then after that, I think on earlier YouTube, I think I've shared that. From here you can go back and see. how these guys were inspecting the bridge, touching it, look at it, even placing formwork, even casting concrete. There are special concrete that they were using which could harden even underwater. So we realized that actually clarity of water is important, like what they are indicated here. If it is turbid, that becomes tricky. It was a bit tricky, of course. These piers are closer to the turbine, and because of that draw effect towards turbine to generate electricity, they would feel some draw up. But because they are professional, they knew what to do. So it is important that underwater, don't just do anything and leave it. Underwater inspection and maintenance is possible, but you need to be ready to identify the right team, the right expert to give you the proper ways of inspecting and also proper technology to do the maintenance if it is required. This is the Horrocks River Bridge 1974, not abutment on the left here and the pier here. This one is the bridge, it was like a steel bridge, but you know, we're telling you that water moves with many things, tree branches. This time it was, I think this like papyrus or water icing or something like, or grass or what. It came and blocked this, got trapped in the truss system, and it became a dam kind of. And now what you never designed for became real. All limits exceeded, and the bridge was swept. Very, very important to know. This is another thing. You can see I told you the tree roots and the rest. Your pier is here. Water is supposed to flow steadily here. But as soon as this thing blocks, the flow pattern, the flow velocity, everything will completely change. And the whole thing is not as per design. You can't even now, if they tell you to quality assure some of the thing, as a designer you can't, because you are using water. So typical flood debris, this needs to be removed urgently because it provides restriction to water flow and causes damming. But what about at the time this thing came? It started, it already caused damage. So you have to be careful. You may find upstream here and near here the scoring started, and that need to be also checked. Very, very important. You can see here, this field tend to undermine the flow, and water start behaving, creating dam effect, and it goes into the deck, and you can see the middle part gone. Two simply supported reinforced concrete deck span washed off their piers by a flood that brought many trees and branches. Maloletsi, Sehukunalen, 1999. Definitely what I'm telling you. We designed for water, but as soon as you think, I don't think we have manuals for this. This is now where we need some subject matter experts. When you do your design, how do you take care of the thing? That is why now when you talk about the resilient structure, climate change adaptable structure, definitely the headroom here wouldn't be this. Now if you bring in hydrologists here and people who are sensitive to climate, they will tell you that you needed to double the headroom here, so that this tree can actually, if it goes down with about 4-6 diameter, it should pass. So you need to head from almost a level. Then the designer will say, an economist will say, the cost aspect. We may not, but again, in the long run, it is worth it. Today you are saying cost, but your bridge will not last for 100 years. You are going to have that one-off rain and flood in the 25th or even 30th year, and that's the end of the bridge. So we need to have thought about climate change. Very important. You see, even the way we do our simply supported, some area I've realized it is not good. Areas that you think we are going to experience extreme velocity and water forces, we need to have it continuous and properly locked in to the pier, so that the whole thing is uniform, integral, and heavy. Then beyond that, we can now do our simply supported. I think this is something we need to buy in. These are Black Folossi River in flood in 1984. You can see this flood. You are going to see what happened. It got blocked. Water came. Water became wild, mud, and it went beyond. You can see it. Now this is it continued building because things debris blocked this area, and this is what happened. This kind of pressure now, you have pressure start from up here all the way down. You have a velocity effect. Then you have, these are all simultaneous forces happening on the bridge. There is now, this is what they call buoyancy happening. You have a push effect, you have a pull effect. Then so many things are happening at the same time, and also scoring is happening. before you know the bridge gets into problem. Look at what happened thereafter. Those that cannot withstand the forces of nature at that moment give way. You see, like these ripe mangoes, when they're up there, they keep falling off. Once they're ripe, they fall. The ones that are gripping onto the tree branches, they still remain. So here, the embankment, we are lucky that this is exactly what I was saying. These are well anchored onto this system, and these are on piles. They survive. Anything that are not properly anchored got swept away. So this is the end of the knowledge sharing. Ladies and gentlemen, unfortunately, I don't give you time for question and answer. Maybe in future, if we start going live, we shall have a better interaction. But at least thank you so much for being a good follower. Please look at that. Why I brought it is because we are doing design, and tomorrow you get. It's about we do design. So what? We must know how this structure will perform at the end of it all. So you start incorporating your maintenance, your inspection in the design. For pier support, access from the roof, from the deck onto the pier, moving under to inspect the deck at the pier area. You need ladder. We need ladder coming from the deck up downward, and then you're able to walk around to see the bearings, clean even the bearings, and do that thing. Very important. Even at the so that access from up, even if the road is very busy, you have no problem. It's not good to and the vehicle from up with that lowering technique. They're okay. They're safe. So long as the traffic guys, they can help. Inspection helps us to identify early defects that will propagate with time and compromise on the functionality and the integrity of the bridges and structures like culvert. So it is important we maintain it. You are going to see when we are discussing on bridge maintenance management. I told you that the expansion joint, the bearings, the guardrail area, the paintings, the asphalt concrete, those are inspected and managed at a certain interval because their maintenance-free life are not the same as concrete, which is about 75 to 100 years. So you find a way at a 20th year you are going to remove and replace the bearing, and the curve of performance goes up. When you improve on the expansion joint, the curve of performance also moves up. So you extend. If a bridge is supposed to fail at 100th year, it will find that it goes by about 20 years. So why inspection is very important, very, very important. Now it is from inspection that we do the planning on how do we now maintain these bridges and structures. I think that is good. Tala, Alfred, Lawrence, Julie, Baton, Christian, Etolu, Musa. You guys need to look at some of the things. Please don't just design. I gave you box culvert recently. We talk about steel bridges. Now, how do you access? How do you maintain? How do you inspect? What are elements to inspect? Checklists are very important. So let us not only do design. Midas may not do maintenance. You must know maintenance. Plan it in your design, and then you design accordingly. I think that is good enough. Thank you so much for this. I hope you find it interesting. Bye-bye.